Good evening, everyone.
Good evening, ma'am.
Good evening. Good evening. How are you all? All good? Yes?
Hello, ma'am.
Hello. Okay then. So today we are going to have week 7 open session. So have you gone through week 7? The lectures of week 7? Yes or
Yes.
no?
Some lectures, ma'am, not completely.
Not completely. Okay. Okay. So do you guys have any idea what week 7 is all about?
Probability.
Yeah, it's all about probabilities. Shall we start with it or should I wait for more minutes? One more minute?
Start.
Okay, you're in the sense, okay, there were some issues in the EMQs, right? How many of you guys had issues with the EMQ thing?
No, ma'am.
No issues? Okay. And about the graded assignment of week 6, the question number 3 of like part 1, the question number 3 will not be evaluated and the rest of the questions will be evaluated. Okay?
Yes, ma'am.
Okay. Okay, let's start then. Now, in week 6, what we are going to study about? We are going to study about the probabilities. Okay. Till week 6, what we were,
Excuse me. Hello.
yes,
Excuse me, ma'am. Will you address the week 6 topics? Not the topics, but questions, assignment questions today.
week 6 assignment questions.
Yeah,
No.
EMQ as well as graded. Mostly EMQ, but if other people have doubts in the graded assignment as well,
Okay.
will you be able to address this today?
Today, okay, let's finish this week 7 theory part and then I'll come back to that week 6. Okay.
Okay.
Yeah. Okay. Now, till week 6, we were all talking about the descriptive things, right? The descriptive probabilities and descriptive things. Okay. Now, from descriptive, we are going to touch, we are going to study about the inferential thing. Okay. What is inferential all about? Inferential is all about studying about the population with the help of sample, correct? Now, if we have to move from descriptive to inferential, we need to know about the probability. Okay. What do you mean by probability? Probability is actually, what is probability?
Number of favorable outcomes divided by all possible outcomes.
Yeah. Or you can say the determination of the chance of happening and of an event.
Possibility.
Or you can say the possibility. Okay. So that is my probability. Okay. So now in the probability, the first thing comes as a random experiment. What do you mean by random experiment?
Experiment which is randomly done.
Picking one experiment randomly out of n number.
Yeah, so basically my random experiment is an experiment whose outcome is not predicted with certainty. That is my random experiment, right? See, let's suppose if I'm tossing a coin, okay? If I'm tossing a coin, I have there are two possibilities, right? Two outcomes. One is head and one is tail, correct? So if I'm tossing a coin, I cannot say with certainty that I will have a head. I can have a head or a tail, correct? So I can't predict the outcome with certainty. So that is my random experiment. Fine? Understood?
Yes, ma'am.
Yes,
Both
ma'am.
the results are prediction only.
Yeah, basically random experiment is that experiment in which we don't know the
Exact
outcome
outcome.
with certainty. Okay. Now comes the sample space. What do you mean by sample space?
The set of all the outcomes of an event or a
Or you can say the
Set
collection
of
of
all Possible outcomes of an event.
Collection of all the outcomes. If I'm tossing a coin, what are my outcomes?
Head and tail.
Head and tail.
Head and tail. If I'm rolling a die, 1, 2,
1 to
3,
6.
4, 5,
4, 5,
6.
6.
So these are my sample space. Okay. So I generally denote my sample space as S. Fine.
Yes, ma'am.
Okay.
Yes, ma'am.
Now next come is the event. What do you mean by event?
Event
The
is our
subset of
favorable
sample
outcome.
space.
Yeah. Yeah. What about others?
It's like having a condition inside the country.
Yeah. So you can say that my event is a subset
Subset of S.
of sample space or S. Okay. So let's suppose my condition is I'm rolling a dice. Okay. So my sample space is basically what? 1, 2, 3, 4, 5, 6. Now I'm taking an event E, which is basically getting an even number. So what are my events? It would be
2, 4, 6.
So it will be 2, 4, and 6. This is my event. So event is basically getting an even number. Got it?
Yes, ma'am.
Yes, ma'am.
Is it fine? Okay. Now comes
Ma'am,
you.
what you have said, getting even numbers,
Yes. Is it
only
fine?
even
Only
only
even numbers. So I have this sample space. So what are my even numbers? 2, 4, and 6. So this is my event.
okay.
Okay. So event is basically what? Subset of our
Sample
sample
space.
space. Okay. Now, what do you mean by union of events?
It's a combination of more than
All the
one
events.
events.
So basically, let's suppose I'm having two events. One is E and one is F. Okay. So if I'm saying that an event which consists of all outcomes that are there in E and F, in both E and F. Okay. So basically, we denote union of event as E union F. Fine. That means my E is also occurring and my F is also occurring. Okay. So let's suppose, okay,
Excuse
let's
me,
take this
ma'am.
example only. Hmm?
Ma'am, is it that they are in both E and F or either E or F? Like all which are in E and F, everything
Consist
is
of
in
all
F.
outcomes that are there in both, means either in E or F. Yeah, correct. Or F. Okay. Now, let's suppose my event E is basically getting an even number, which is 2, 4, and 6. Okay. And F is an event which is getting an odd number. So basically it is 1, 3, and 5. So what will be my E union F? It will be
Null set.
1,
All
2,
elements of the E and F.
correct. Okay. This is my union of events.
Yeah.
Is it clear?
Yes, ma'am.
Yeah. Okay. Now comes the union is okay. Now comes the intersection. What is intersection?
So common elements.
The common elements of the two
Common
sets.
between both
Common
the
elements of the events.
Yeah, common elements. You can say that. Okay. And it is denoted as E intersection F. Okay. Okay. Let's suppose I have okay. E is HH HT. Okay. And F is DT and HT. Now, can you tell me E intersection F,
MH.
HT.
HT.
which is HT?
Only HT.
Okay, so this is my intersection, which is common in both of the events. Okay, that is my intersection. Now, what is it? Okay, null events. What are my null events?
Zero outcomes.
So basically, this if they don't have any outcomes. then I say that it is an null event and it is denoted by phi. Okay. So there is one theorem in which if my E intersection F is a null event, then we say that my E and F are mutually exclusive. Or you can say disjoint
Unique.
events. Fine. Just remember this thing. If my E intersection F is phi, that means there is no common point, no common element. Okay. If there are no common element, then I say that my E and F are mutually exclusive or disjoint events. Is it clear?
Yes, ma'am.
Yeah. Okay. Now comes the, sorry.
We can say that both the events are unique.
Both the events are unique. You can say that. Now, then comes an event complement of it. What do you mean by complement?
And availability.
Huh?
It's inverse or reverse.
Yeah.
Have all the elements which are present in the superset, but not on the event.
So let's suppose I'm having an event. I'm having a sample space S and an event E. So basically, so if I have to find out the complement of E, so I will denote
S
it as
minus E.
EC. So this EC will be consisting of all the outcomes which are not there in E. That means S minus E. This one.
Yes.
Okay, which is denoted by 1 minus E. That is total minus the event. So this is my complement. Fine.
Yes, ma'am.
It is basically consisting of all the outcomes that are not there in E. Got it?
Yes, ma'am.
Okay. So let's suppose if I'm having what all, okay. Let's suppose I'm tossing a coin. Okay. And my one time. Okay. My sample space is H and T. Okay. Now my event E is basically what? Getting an head, which is H. Okay. Now, what will be my E complement?
Tail.
It will
Tail.
be tail.
Tail.
Okay. So basically, E complement is basically what? The outcomes which are not there in E. Fine. So this is my complement. Now comes subset. What do you mean by subset?
All the elements present in the set.
Part of a union of set.
Part
Union.
of a set.
Or the universal. Yeah, we can say that the set of the universal set. Part of the set of a universal set.
So let's suppose I'm having two events E and F. Okay. Now if all the outcomes of E are also there in F, so I can say that my E is a subset of F.
Subset of F.
Okay. So and similarly, if I say that all the elements of F are there in E, I can say that my F is a subset of E. Got it? So let's take an example. If I'm tossing a coin. Okay, so my sample space, if I'm tossing a coin two times, okay, my sample space will be HH, HT, TH, and TT. Correct? Now, let's take an event E, which is basically getting a head on first toss. So it will be HH and HT. Correct? Yes. Now, let's take an event as F, which is basically getting a head on both the tosses. So basically, this will be HH. Now I can say that my F is a subset of E. Yes or no? Because the outcomes,
ma'am.
all the outcomes of F are there in E also. Got the point?
Yeah.
Sure. All of these things are clear. The null
Sure.
events, complement, intersection, union, events, right? Okay. Now comes the Venn diagram. What do you mean by Venn diagram?
Visual representation of
Pictorial
probability.
representation.
Diagram.
Yeah, basically it's a visual representation. So in this, we make a rectangle. Okay. This rectangle is actually my sample space. Okay. Then in that we can make an event. So event is basically denoted as like, or you can say a circle. So
Circle.
this is my one event. Okay. Now this is my one event. Let's suppose I have two events. Okay. Now this is my sample space, which is S. Let's suppose I'm having two events, which is one is E and the other is F. Okay. So this is my F and this is my E. Now, if you look at here, this all thing is my E, correct?
Yes, ma'am.
And this whole thing is my F.
F.
Now, what is my E intersection F?
The both color shaded part.
So you can say that this part. Yes or no?
Yes, ma'am.
Yeah. This is my
Yes, ma'am.
E intersection F. Okay, which is the purple part. Okay. Now, can you tell me what is my E union F?
That's combination of blue,
Combination
purple,
of
and
both.
red, ma'am.
Yeah, it is basically the whole part. Correct?
Yes, ma'am.
That is my E unit. So this is how you make a Venn diagram, or you can say physically, like graphically represent a probability thing, and events, a sample space, and everything. Okay. So this helps you to solve some questions and all. Fine. Okay. Let's suppose, okay, this is my sample space S, and we studied about numbers. Okay. Now, there are two events. One is E, okay, and the other is F. Now, can you tell me from this figure what can you tell us about the two events?
Separate
And both
events.
are disjoint.
Both are
Disjoint
disjoint.
events.
Yeah, correct. Both are disjoint. Now, next, if I draw, this is my sample space. Um, okay. This is my E, and this is my F. Now, what can you tell me about the both events?
E is a
Ma'am,
subset of F.
of F.
E is a subset of F.
Subset
Okay.
of F.
So, yeah. So this is how you can represent a sample space, an event, or a random experiment or something. Venn diagram is clear?
Ma'am,
Hmm.
subset need like initial elements to the till the full elements, right? Last elements. So E is like inside F.
Huh.
So it is not subset, I guess.
Sorry, once again.
Ma'am, F inside E, right?
E is a subset of F, na? That means all the outcomes of E are there in F. So if you see here, my E is inside of F, na? So all the elements that are in E are also in the F also, right?
Yes.
Yeah. Fine. Can I proceed?
Yes, ma'am.
Okay. So this was all about Venn diagram. Now comes the probability. Okay. Now in this probabilities, okay, we have three main interpretations. Okay. So the first interpretation say that, which is basically a classical interpretation. Okay, classical theory in which it says that my probability of uh, probability of having an event E is basically my M upon N, which is my M is
Total favorable
Number of favorable outcomes.
favorable
Favorable
outcomes.
outcomes by
yeah
the total
number
number of
of
outcomes.
yeah it is actually number of favorable outcomes,
By
and
total number
N
of
is
By total
the
number
outcomes.
of
total
outcomes.
Total
number of
number of outcomes.
outcomes. Okay, this is my classical theory of a probability. Then comes a relative theory. Okay, or you can say the empirical theory, in which it states that my probability of happening an event E is basically limit n tends to infinity. That means if my random experiment goes on and on, very long, okay, infinite times. then it will be what? Number of times it has occurred upon number of outcomes. Then comes the third theory in which we actually like we take a guess, right? In the sense we say that we have a 30% chance of happening a rain, or like 50% chance of failing that exam or something. We take a guess. So these are the three theories, or you can say three main interpretation of a probability. First is classical, then relative frequency, and then take a guess. Okay, so these are the three things. Now in probabilities, after all of these, we have three axioms of probabilities. These are not main things. This is just a simple thing. Okay, you don't have to go into deep into this. Okay, the main thing is you have to be aware of the axioms of the probabilities. Okay, what are the axioms of probabilities? The first axiom of a probability is that my probability of an event should be between zero, should be between and equal to 0 and 1. Okay, if you are finding a probability, it should be between 0 and 1. Fine. Now, second, what it says that the probability of a sample space should be equal to 1. Okay. And third says that if, okay, if let's suppose I'm having events E1, E2, En events I'm having, let's suppose. For now, till now, I'm taking, infinite. Okay, let's suppose infinite events. These are mutually exclusive events. Okay. Then probability of union of all of these events where my I is going from 1 to infinite will be equal to the sum of each of the probabilities.
And if two events are mutually exclusive, can we say that one of them does not depend on the other?
One of them?
That one of them does not depend on the other event?
That is what. So if let's suppose if I'm having two events, E1 and E2, both are mutually exclusive. I'm just denoting mutually exclusive as common. Okay. So let's suppose my E1 and E2 are both mutually exclusive. Then probabilities of E1 plus E2 will be equal to what? Probability of E1 plus probability of E2. Fine?
Yes.
Okay. Now these three properties are the important properties of a probabilities. From these three properties, we can find out some like general the general properties of probabilities, which were the complement of an event and the sample space is 1 equal to 1. So through that we are through these axioms only we are trying to prove all of the other properties of the probability. Okay. Now, yes,
Can you explain the third one once again, Matt? That sigma one.
sigma.
That E1,
So
E2 are mutually exclusive. The summation one.
yeah, summation one. It is actually saying that if I'm having E1, E2 infinite events, which are mutually exclusive, this is the main thing. If I'm having mutually exclusive, that means both of the events are not having any common elements, correct? That are my mutually exclusive events. So if I'm having infinite number of mutually exclusive events,
So
okay,
each
then the
event is unique there. Each event is unique there.
yeah, it can be said that it can be unique. Yes. Okay. So if then the union of all of the events, E1, E2, like that, will be equal to the sum of their probabilities.
Yes.
Okay. So let's suppose if I'm having two events, E1 and E2, they are mutually exclusive. Then the sum of their probabilities, which is probability of E1 plus E2, will be equal to the sum of their individual probabilities. Fine.
Yes, ma'am.
Okay. Now,
Ma'am, but the condition is that it should be mutually
mutually
exclusive, right?
exclusive.
Okay, okay.
Now, here comes comes the addition rule of probabilities. Now, what it states that, let's suppose I'm having two events, E1 and E2. Okay, they are not mutually exclusive. Okay, means they are not disjoint. Okay, when they are not disjoint or mutually exclusive, then probabilities of even union E2 will be equal to probability of even plus probability of E2 minus probability of even
E
intersection
intersection. Yeah.
E2. Okay, just remember this thing. This thing is valid when I have a mutually exclusive events. This thing is valid when they are not mutually exclusive. Fine?
Yes, ma'am.
Yes or no?
Yes, ma'am.
Okay. Now comes addition. Okay. Now comes the equally likely events. What do you mean by equally likely events? Anyone? Anyone?
Probability of
Almost the
a
same
particular
probability.
element is same as the other element.
So let's suppose I'm rolling a die. Okay. Now my sample space would be what? 1, 2, 3, 4, 5, 6. Right? Now the probability of so I'm saying that they are equally likely. Okay, these are my outcomes, right? So they are my equally likely outcomes. That means probability of occurring 1 is equal to probability of occurring 2 is equal to probability of occurring 3 till probability of occurring 6. Okay. Now, what is the probability of occurring of 1? Occurrence of 1? It will be what?
1/6.
1
1
by
by
6.
6.
6.
Similarly, probability of occurring 2 will be also 1 by 6.
1/6.
That means all the probabilities of occurrence of an of the outcomes will be equal to 1 by 6, or you can say 1 by n. In general terms, if I have to say, it will be 1 by n. N is basically the number of outcomes. Fine?
Yes, ma'am.
Yeah? Okay. Let's suppose this is my sample space, which is rolling a die. Okay. Now, I am specifying an event E, which is basically getting an odd outcome, right? So what is my E? What will be my outcome? It will be getting an odd. It will be 1, 3,
3 and 5.
and 5. Okay. Now, what is the probability of A, in the sense probability of E?
Probability of
E. It
3
is
by
an equally
6.
likely,
1 upon 3.
Even, ma'am.
it will be 3 by 6,
3 by 6.
right? Which is 1 by 2.
Yes, ma'am.
Got it? What is probability of E? Probability of E in the sense, which is probability occurrence of 1 plus probability of occurrence 3 plus probability of occurrence 5. And all of these probabilities are 1 by 6, 1 by 6, 1 by 6, which is actually 3 by 6, which is 1 by 6. Fine?
Yes, ma'am.
Okay. Okay. Let's suppose I'm having another event which is actually getting a number which is greater than 4. Now, what are the outcomes? It is actually
5, 6.
5
5
and 6.
and
2 by 6.
6. And what is the probability of getting an F?
2
Which
by
is
6.
2 by 6. That is
6.
1 by 3. Right? So this is how you calculate the probabilities for an equally likely outcomes. Is this thing clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Let's solve some question. Just to give me a minute. I'll just look into the questions.
Ma'am, the open session notes of week 6 is not uploaded in the open session notes.
Sorry, once again.
I mean, the
Once
week
again.
6 open session notes are not uploaded.
Week 6 open session. Who took it?
It's not there uploaded in the drive.
Yeah. Can you tell me who took it? Who took the class?
I
Ma'am,
guess
week
it was on Monday.
6, you only took it.
I only.
Yeah, the combination, like you only took it.
Okay. Okay, I only. Okay. I'll just upload it now.
Along
Okay.
with week 7.
Yeah, week 7. Okay. By today, okay. Can I upload week 7 after the doubt session?
I guess it is better if we can upload it before Sunday.
Before some. Okay. Okay. Now, let's suppose my sample space is 1, 2, 3, 4, 7, 8. Okay. Then there is one event E, which is actually 1, 2, 5. Then I'm having an event F, which is 4, 6, 7. And G is one more event, which is 1, 3, and 8. Okay. Now, can you calculate what is my E union F? Then you have to tell me about E intersection G. Then F union G complement. Then
Ma'am, elements of G 1, 3,
8.
8. Okay.
okay, all of these you have to tell me.
First one is 1, 2, 4,
1,
5,
2, 4,
7,
5,
6,
6,
7.
7.
A intersection G is
Only
1.
1.
1. That's all, ma'am.
F union G complement.
1 to 5.
Okay. So if I
It's
write
2.
this, I can write it as 1 minus F union G.
Yes,
Yes or
ma'am.
no? Yeah.
Yeah.
Now,
Perfect.
what is my
2 and 5, ma'am.
what is F union G?
1, 3,
1, 3,
4,
4,
6, 7, 8.
6, 7, 8.
Okay. Now, 1 is basically my sample space. So if I subtract it from the sample space, it is coming out to be 1 is out. So left with 2,
2
3,
and
4,
5.
5. Yeah, that's it. And what about the other?
Yes, ma'am. 2 and 5.
Yeah, 2 and 5. This thing is clear? The third part to everyone?
Yes.
Yeah? Okay.
ma'am.
Now, what about E union F intersection G? So you can, okay. So
F
the
intersection
thing,
G is null set.
And
F
1, 2, 5.
intersection G
Is one.
Yes, ma'am.
Null
F
set.
intersection G is null
Null
set.
set.
is a
And
Therefore, it's
null,
one.
going to be
null
1,
set.
2,
1 to
and
5
5.
is
1,
the
2,
set.
and 5. And
1, 2, and
1 to 5. That's
5.
it.
Okay. So this question was clear?
Yes, ma'am.
Ma'am, option 3.
And option 3 what?
मैम फिर से बता दीजिए आई डोंट अंडरस्टैंड
देखो F यूनियन G का कॉम्प्लीमेंट का क्या मतलब हुआ 1 माइनस मतलब जो भी F यूनियन G में जितने भी एलिमेंट्स है उसको हमें सैंपल में से माइनस करना है करेक्ट वही हमारे एलिमेंट्स होते हैं कॉम्प्लीमेंट में
यस मैम
ठीक है अब F यूनियन G में कितने एलिमेंट्स है हमारे पास ये वाले एलिमेंट्स है करेक्ट 1 इन द सेंस होता
यस
है
मैम
हमारा पूरा टोटल में से दैट इज सैंपल स्पेस में से हमें ये माइनस करना होता है करेक्ट मैं सैंपल स्पेस क्या है ये है उसमें से अगर मैं ये एलिमेंट्स माइनस करूँ तो मेरा कितना बचता है 2 एंड 5
ओके मैम समझ में आ गया थैंक यू
ओके नाउ okay
Generally we write like this, F union G complement is equals to 1 minus F union G. This generally we write for the probability, na?
हाँ you can write it like that as well but for the simple like if you make like for your understanding okay this case is actually for the probability only but if you like I just wrote it in for the simple case like making it simple for the other people to
Okay.
understand okay
Okay.
this is basically done for the probability that you are right but to make it simple I just have written like this okay
Okay.
Okay. There is one question of activity 7.4, question number 3. Okay. So a customer will purchase a shirt with probability 0.4. Okay. The probability of purchasing a shirt is actually 0.4. Then the customer will purchase a pant with probability 0.3. Okay. And will purchase both a shirt and a pant with probability 0.2. So I'm having S is actually shirt. Okay. And P is actually my pant. Now, can you tell me uh, the the probabilities? What should I write here for will purchase both a shirt and a pant with probability 0.2?
S intersection
S intersection P. Okay. So this is basically what? Will purchase both a shirt and a pant. Okay. Now you have to tell me what is the probability that the customer purchases neither a shirt nor a pant. That means I need to find out probability
0.5.
of, yeah. Can you tell me what is the probability that I need to find out?
S union P whole complement.
S union P
S
whole
union
complement.
P
Complement.
or
Yeah.
1
Actually, I
minus
need to find
1 minus S union P.
S union P. Okay. Can you guys find out this? Can you tell me what is probability of S union P?
0.5.
How did you calculate this? It is
0
basically
0.5.
my S and P are not mutually exclusive. So I will be following the addition rule, which is probability of S plus probability of P minus probability of S intersection P, right?
Yes.
So if I put the value 0.4 plus 0.3
0.3
minus
minus
0.2.
0.2,
So
0.5.
this is actually 0.5. So now probability of S union P complement will be equal to
0.5.
complement. So this is 1 minus 0.5, which is 0.
0.5.
Okay. Now, there is one more question, question number 4. Shabnam has 74% chance of receiving an A in either statistics or mathematics. Okay, let's suppose my statistics is denoted by S and mathematics is denoted by M. Okay, now they are saying that Shabnam has 74% chance of receiving an A in either statistics or mathematics. That means probability of S union M is given to be 0.74, correct?
Yes, ma'am.
Okay. Now you need to find out the probability that she does not receive an A in either stats or mathematics. That means I need to find out the complement of this.
Yeah.
So they are saying that she does not receive A in either stats or maths. Got it? That means S union M whole complement. Yes or no?
Yes, ma'am.
S union
Sure.
M.
It's clear to everyone, the question?
Yes, ma'am.
Yeah? Okay. So this will be what? 1 minus 0.74, which is actually
0.26.
0.26. Okay. So if it's about either and or, it is actually talking about union. Okay. And if it's talking about and both S, A, E, and F, I can say that it's talking about the intersection part. Fine. Yes.
Yes, ma'am.
Okay. And 7.6, one question will get from here. Okay. Let's take question 5 from activity 7.6. Suppose that when 2 dice are rolled, each of the 36 possible outcomes is equally likely. Okay. So if I am rolling a dice twice, okay, how many outcomes are there? If there are 36 outcomes, correct? And they are saying that these are all equally likely. What do you mean by equally likely?
Possibility of same occurrences.
Yeah, occurrence. That means probability of occurring of like one number is like 1 by 36, something like. So every outcome is equally likely. Okay. Now find the probability that the
Hello?
sum of the
Hello,
yes,
ma'am.
yes.
Why we have taken S is equal to 36?
S is the number of outcomes. How many number of, or you can say this is my N, let's suppose. N, right?
Yes.
Ma'am,
And this is the question. This was
ma'am, what
Yeah.
is
question.
equally likely? Can you repeat it once more?
Equally likely, they are saying that I'm rolling a dice twice. Okay. So that means there are 36 possible outcomes. Yes or no?
Yes, ma'am.
Okay. Now these all 36 possible outcomes are my equally likely events, outcomes. Got the point? What is equally likely? That the occurrence of all of the outcomes are equal. Fine? Yes or no?
Can you give an example?
Ma'am, if we are rolling the dice twice, then how it is how n is equal to 36?
Okay.
Maybe 2 days at a
Yes,
time.
ma'am. Yes,
2
ma'am.
times 6 into 6.
Yes, ma'am. It will be. Yes.
It will be 6. Sure.
Yes, ma'am.
Okay. So what I was saying. So there is a dice. There are 36 possible outcomes and all are equally likely. Now you need to find out the probability that the sum of the outcomes of rolling the two die is 6. Can you tell me that?
2,
It can
4,
be 1 comma 5, 1 comma 5,
3,
5 comma
3.
1.
1 comma 5, 3 comma 3.
Ma'am, we can
So
do it
you are
two ways,
telling
ma'am.
me the
After 1,
outcomes. Okay.
Yeah,
You are telling me
Correct
the
outcomes,
outcomes.
madam.
Okay. 1 comma 5.
1 comma
Then
5,
and
2
2
comma
comma
4,
4,
uh,
3
2
comma
comma
3,
3 comma 3,
4 comma 2,
4 comma 2,
5 comma 5,
5
comma
comma
1,
5 comma 1, and
and that's
That's
all.
it.
that's it. So how many are there? There are in total. So
5.
probability of,
5 by
so let's suppose my
36.
E, it will be 5 by 36. Okay. So this is how you have to do a quite like the equally. So we have done the equally likely thing. Then we have done the complement of this. Then we have also used the additional property. I think everything is done. Yes. So this was all in week 7. Is week 7 clear?
Yes.
Yes, ma'am.
Sure. Any doubts?
Ma'am, for a last question, what is equally likely for last question?
Equally likely in the sense um if I'm having how do okay so these are my outcomes of these are my probability of getting the sum as 6, right?
Yes.
Okay. Now this is 1 comma 5. That means at the first toss, at the first rolling, I am getting event at 1. Then I'm getting a 5. Correct? So what is this probability? It is actually 1 by 36. This is 1 by 6. This is 1 by 6. If I multiply it, it is 1 by 36. Yes.
Yes, ma'am.
Similarly, for 2 comma 4, it is also 1 by 36.
Yes, ma'am.
Yeah. Similarly,
Yes,
I am
ma'am.
having 3 for 3, 1 by 36. So for all of them, so basically my probability of event E is actually what? Probability of event E1 plus E2, E3, E4 plus E5, which is actually 5 by 36. Yes? Or you can also say it like this. See, I have an outcomes like this, right? 1 comma 1, 1 comma 2, 1 comma 6. Similarly, 2 comma 1, 2 comma 2, 2 comma 6. Like this, I'm having, right?
Yes, ma'am.
So they are saying all of these are equally likely. That means the occurrence of 1 comma 1 is actually what? 1 by 36. Occurrence of 1 comma 2 is actually what? 1 by 36. Similarly, occurrence of 6 comma 6 is actually 1 by 36. Got the point of equally likely thing?
Yes, ma'am.
Okay. Equally likely means the probability of, like, if there are how many outcomes are there? There are 36 outcomes, right? So probability of happening of a one event is actually what? 1 upon 36. Similarly, probability of occurrence of the second event is also same as the first event, like that. All of the occurrence, the probability of occurring of an event is same for all of the outcomes. Right?
Yes, ma'am.
Okay. So that was all in week 7. Okay.
That was all in week 7.
Yeah, this was all about in week 7.
Oh, okay.
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 Oh, that's it. Any doubts on week 7
No.
in the theory part?
Ma'am, today we will be discussing week 6 doubts, ma'am. Will you take
I
graded
can
assignment doubts?
graded assignment. Okay. Is it that confusing? Have you gone through the weeks? Okay, week 6 solutions have not been uploaded, right?
Yes, ma'am.
Ma'am, before
Okay.
Wednesday, before Sunday, week 7 and week 6.
Uh, yeah, I'll just upload the graded assignment solutions.
Okay.
Okay. So we can have the doubt session for week 7 for sure. Okay. Tell me.
Okay, ma'am.
Okay. What are your doubts?
Ma'am, graded assignment, ma'am.
Graded assignment.
Can you take the
Question number?
Okay. Thank you, ma'am.
Thank you.
Ma'am, question number 5.
Thank you.
Question number
5.
5. Someone has 5 plates of different types and she wants to wear every day the different It is some reason.
Hello, ma'am.
Yes.
Can you now, will you now be able to address the week 6 EMQ problems?
Right
Like
now
the
I'm
doubt.
just solving the graded assignment question.
Oh, okay. Another thing, ma'am, like, are you going to solve each and every single question, or
No.
you're just going to allow
I
some time for people to ask doubts from
Yeah,
graded assignment only?
correct.
Oh, so till what time are you going to allow for the graded assignment part, and when are you going to move on to EMQ?
It depends upon the students only. If they have, if only 2 of them are having doubts, then it will be completed early. It depends upon you only.
Uh,
Okay.
okay, ma'am. So till now you haven't gotten any doubts for the graded part,
Yeah,
graded assignment.
I have got.
Oh, you have. Okay. Sorry.
You are
Continue,
not
ma'am.
attending the live session.
Actually, I came here specifically for the week 6 part. That's why.
You are done with
More
week
than
7.
the No, ma'am. I want to complete week 6 and only then proceed to week 7. Like, I want
Okay.
to get a thorough understanding of week 6 and only then.
Right now I just explained week 7. Is it clear, or did you even listen?
Um,
No.
yes, yeah. You were just, talking about the basic axioms of probability, mutually exclusive events, just the basics, right?
Hmm. Okay then. Yeah. Just give me a moment. I'll just complete with the graded assignment, then I'll come back to you. Right?
Yeah, okay.
Okay. So the question is, so
Ma'am, क्वेश्चन नंबर 5 शेयर चैट
Huh?
में शेयर की क्वेश्चन नंबर 5
Yours is different. Yeah, I'm
चैट
just
में
reading
शेयर
that.
की
Yeah, I'm
Yes,
just
ma'am.
reading that only. Someone has 10 clothes and she wants to wear other these for a different day. Okay. So they are saying that. Okay, so they are saying that in total I'm having 10, Suman is having 10 clothes. Okay. 10 different types. That means I'm having 10 different types of clothes and 10 days. Now they're saying that C1 must be used either at, so that C1 is one type of cloth, it should be used in day 8 or at day 9. So I'm having two ways to use the cloth one. Now they're saying that C2 should be can either be used in day 9, day 8 or day 10. And they're saying that every cloth is to be used at only one day. So C1 is already, it can be used in day 8 and day 9. Then C2 is having two ways, right?
Yes, ma'am.
To be used, correct? Because one is already there, like one is already occupied by the cloth one, correct?
Yes, ma'am.
Okay, then.
7.
So we have 10 days,
I
right?
did this, it was wrong. Like what I did was C1 I did one thing that I take that first one D8 say for example, and for C2 there are three ways, and plus there is another case that is C1 D9, and for C2 that the D8 and D10, so there are two options, and then added both the cases, but the answer came like 36 56 like that, but the answer was wrong.
Okay, let me just also, do it. Okay. C1, C2. Then comes the C3. Okay. So in total, three are there are two ways. So D8, D9. Now, how many days are left? 1, 2. So 2 is there. So I am having 8 days left, correct? So I'm having 8 ways to choose that. Then for C4 also I'm having 7 ways. Then C5 I'm having 6 ways. C6 I'm having 5. C 7 I'm having 4 ways. C8 I'm having 3 ways. C9 I'm having 2 ways. C10 I'm having 1 way. Okay, you got this? See, um, choosing a cloth like choosing a cloth one on like for one day is like I'm having 2 ways, right? It can be worn in day 8 or day 9, right? So I'm having 2 ways to wear that cloth. Similarly, for cloth two, I'm having 3 days, three choices, but one day is already occupied by the cloth one. So I'm having only 2 ways. Now, the days are I am having one close is already chosen, second is also chosen. For the close three, I am having 2 days are already chosen. So in short, I am having 8 days left, right? So I am having 8 ways to wear the cloth, right? Similarly, for the fourth cloth, I am having 7 ways, six, five, four, three, two, one. Now what you will do, the probability of getting that will be uh, wearing the clothes can be used at basically what? 2 into 2 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Fine?
Yes, ma'am.
Yeah.
Yes.
Okay.
Ma'am,
Yes.
total ways that 2 into 2 into 7 factorial, right? Total ways
2 into 2 into 8 factorial.
factorial. Okay.
Okay.
Hmm.
That's it.
Yes, ma'am.
No more questions from the graded assignment. Many of you are having the doubts, and only one person is asking me.
Question number
Hmm.
6, ma'am.
Question number how many 17-digit numbers can be formed constantly? There is the same way from either of the side. Okay.
Ma'am, the answer will be like 4 into 8 factorial, like the previous one.
4 into 8 factorial. What is the answer coming? You have to, I think you have to solve it. Like you have to multiply all of these numbers.
It's very huge number. What was the answer given?
Yeah, it will be a huge number. The answer is given to be 161280.
1212. Okay.
Ma'am, but the actual answer is different, ma'am.
Yeah, the answer is 161280, no? The answer, accepted answer.
Ma'am, there's an ambiguity here. I think that 4 into 8 factorial should not be equal to that number. It is much greater. I am multiplying the numbers. It's huge.
I'm getting the answer.
No, ma'am. Actually, I did the same way like you did, but did not get the answer. Like in the portal, the answer was something else. That's
The
that's why
portal,
I
the
had.
answer is same only.
That's why I had.
In mine it's showing 161280 only. In yours, what it is showing?
Ma'am, in chat, 20,160, ma'am. That guy, he has sent the
Yes,
pic, you
ma'am.
know.
So how many clothes they are showing? They are showing and 9 clothes are there, na? In mine it's 10 clothes. In yours it is 9 clothes. So the answer will be different.
Okay, ma'am. Ma'am, actually, let me check today. If possible, can I post in the Discord? Will you reply there?
Sure.
Okay. Thank you,
By
ma'am.
today or by tomorrow I will reply.
Oh, ma'am, today only I will post in the Discord. The
But
statistics.
it is but if I'm able to do it, if I'm able to, or by tomorrow I will just give you the reply. Right?
I will solve it and I will post the picture. If you can just see and check that one, I will solve it and post the
Okay.
picture.
Done.
Okay.
Ma'am,
Okay, ma'am.
was the student actually referring to the Google Groups or some other chat application?
Discord.
Discord. Like the links were shared or what? I mean, this is new to me. I'm sorry.
Because most of the students did not get the access to Discord still, madam. Maybe
Yeah,
after
because maybe that you have to ask the support team actually.
even we have
Madam, what
sent
is
the
Discord,
mail.
ma'am?
Discourse is for the term students and discussion forum is for the qualified students. Okay, so if you have completed the qualifier and like if you are past the qualifier, then only you will get the like the student ID. Then you can post it out. Like then you can get the link for the discussion forum. Discourse.
Ma'am, even after getting the qualifier cleared, still we are not assigned that ID. Even though we are given the mail to them, but they are telling that we are getting shortly.
Yeah, so this is not under my thing. This is
Yeah, yeah.
under the support team.
This
So if you have
discourse I
any
am
doubts,
discussing. Discourse, we
huh,
are missing the discourse and other resources which are useful to us, and quiz
that
2
is,
is
yeah.
coming
So if
fast.
you are, so if you are in the like if you have got the IDs and all, then you can be in the discourse. But other than that, you can just put all the doubts in discussion forum. But if you're also putting the in the discussion forum, then also your doubts are being cleared, right?
Yes,
Yes
ma'am.
or no? Yeah. So you can, if you have any doubts, just put it in the discussion forum. There, I am also there, so you can put it. Okay?
Ma'am, I have one doubt, ma'am.
Ma'am,
Yeah,
ask first.
I'm just looking into that only. How many 17 digit numbers can be counted? Whether read the same way from either of the side. From either of these.
Ma'am, I have one doubt, ma'am.
Hmm? Yeah, just let me just finish this thing now. Just a second. Give me a minute. Okay. So they are saying that it's a palindrome, right? That means like all the numbers, like this will be same as the last digit, then the second will be same as this. So this is how I can write it, right? Now,
Yes,
the main
ma'am.
thing is if I just calculate this thing, it will be same as this thing only. Yeah. So now, because this one number, this first digit that I'm filling is same as the digit that is getting to be filled here, right? Similarly, the digit which is getting to be filled in the second place, it's same as this digit, correct?
Yes, ma'am.
Yeah. Okay. Now the first digit it is like how many ways I can fill the first digit? It can be filled in 9 ways. Yes or no?
Yes, ma'am.
Okay. And now
Because
the zero is not added. Now the rest of the places, these rest of the places, okay, this rest of the places can be filled in 10 ways. See, they have not said any repetition thing or anything, right? So I can repeat the letters as well, repeat the numbers as well, right? So I'm having, so filling the second place is also 10 ways, filling the third place is also 10 ways. So in short, I'm having 10 raised to the power 8.
yes, ma'am.
Yeah. So this is how I can choose like I can make a 17 digit number. And this thing that I have chosen is same as this replica of this, right? So this is the number of ways I can, like in this way, I can form a 17 digit number. Fine? Yes or no?
Ma'am, why 10 power 8, ma'am?
अच्छा देखो
Only
1 2 3 4 5 6 7 8 and 9. Okay, these are the digits that I have to fill, correct? Yes or no? Now the first digit is to be filled with 9 ways. Yes.
yes, ma'am.
Okay. Now the second digit will be filled in 10 ways. Yes or no?
Yes, ma'am.
Then the third digit will be filled in 10 ways.
Yes, ma'am.
Okay. Similarly, 4, 5, 6, 7, 8, 9, 10. These are all filled in 10 ways.
Yes.
So how many 10 are there? 10 raised to the power 8.
Yes, ma'am.
So this will be what? 9 into 10 raised to the power 8.
So the last part we should not include the reverse part.
No, 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 no. That should not be included because we are just copying these numbers in here only. Na? So what are the ways in which I have chosen this? I'm just repeating it this here. It's a mirror image, right?
Yes, ma'am. Okay, ma'am.
है Fine?
Okay, ma'am. Thank you, ma'am. Understood.
Okay. Okay. Now anything else?
I'm third also, ma'am.
What third question?
Yes, ma'am. Third question.
Yeah. Can you just wait a moment? Just a second. Okay, just give
Yes.
me a moment. Okay, then third question, right?
Yes, ma'am.
Third question. There are 11 train stops between Chennai and Assam. How many train tickets to be printed so that a person can travel between any of the two stations? So that means order is there. So that means I need to find out 11 P2, right? Yes?
Yes, ma'am.
Yeah, that's it. You have to do the permutation only. Because see, I have 11. Oh, sorry. They are saying that from Chennai, between Chennai and Assam, I'm having 11 stations. So in short, I'm having how many stations? 13 stations, right? Now
Including
from
Chennai. Assam, ma'am.
Chennai and Assam, including Chennai and Assam, I'm having how many stations? 13.
13.
Okay. Now, they're saying that I have to, yeah. So they are saying that how many train tickets are to be printed so that the person can travel between any of the two stations, right?
Yes, ma'am.
Okay. So now if I have to book a ticket, I will be like two ways I can do that, right?
Yes, ma'am. Up and down.
So yeah, up and down. So it will be 13P2 and here the direction matters, right? The order matters. So I will be using what? Permutation.
Ma'am, here what the order means, ma'am? The
They are
going
saying that,
coming
let's
back are
suppose,
different.
what?
Going to Assam and coming back to Chennai are different. This is the order,
So if
ma'am.
this is the order. They are saying that the tickets that I am booking from A to B is different from B to A.
Okay, ma'am.
Yeah. So if the direction matters here, that means order matters. If order matters, then I would be using what? Permutation.
Yes, yes, ma'am.
Okay. Yeah, that's it. Anything
Then
else?
question for this question only. I did this way, like I made, like I solved it fundamentally using my concept that the same thing because going to one place and coming back to one place is treated differently. So what I did is I made like the 11 stations, 13 dashes I made, and then from one dash to the stairs, two dash there are two ways from there to again the next one with two ways, and then I multiplied all those ways, and that way my answer came different.
How? Can we repeat it?
Yes, ma'am. I'm telling it. Like there are 13 stations, right? So what I did is that I wrote down S1, S2, S3, S4 up to S13, and then what I did is S1 to S2 and S2 to S1 is ticket difference. So there are two ways to book the ticket from there to there. And then from S1 to S3, S1 to S4 up to 13. So up to 2 to the power that much. Then again S2 to others. So 2 to the power that much. So and I multiply all those ways. And that way the answer what was coming was different.
S1 to S2, then S2 to S1, then S1 to S3. You took all the conditions.
Yes, all the conditions.
So, so this is two ways, then two.
Now let's take a short example. For example, there are two stations.
So
And
there are.
from
So it will be S1 to S2, then S2 to S1, correct? So there are only
S2,
two ways to do it, right? Let's
no,
suppose
ma'am.
I'm having three stations, S1, S2, then S3. Then it will be what? S1 to S2, then S2 to S1. Then I'm having
Yes,
S1 to S3, then
yes,
S3 to S1, then
yes,
S2 to S3, then S3 to S2. Anything else? Then how many ways are there? 1, 2, 3, 4, 5, 6.
yes.
Yeah.
Similar thing did. Yes, ma'am.
So
But the
you must
answer
have,
was
but the answer is coming out to be different.
yes, ma'am. That is the problem. I cannot understand why.
That I have to look actually. What is it? This is a very long thing.
Not that way. I didn't count, but what I did is S1 to S2. So there are two ways. S2 to S3. There are two ways. S3 to S1. There are two ways. So that way.
So if it's S1
Add
to
the six.
S3,
So
S3
it's
to S1. So in that S3 to, have you taken S3 to S1 two times?
S3 to S1 two times. Yes, ma'am. Because
That is
going
the
at
issue, no? You can't take S3 to S1 two times. If it one time is already, then why are you taking two times? Maybe that is the issue.
okay, ma'am.
Okay, check
I
that.
think,
Okay.
but going S3 to S1 is same as S1 to S3. That's why it took two times, I guess.
Sorry?
No, actually, the question demanded that they should be treated different. That's why I took like. Okay, ma'am. I think that should be the problem. I will cross check that one right today only.
Oh, okay. Anything else?
Last, ma'am. Question number 2.
Okay. I would say divisible. Four, it should be divisible by 4. That means it should be a multiple of 4, na? Right. So if I have numbers like, okay, what are my numbers? 0, comma 2, comma 4, comma 5, comma 7, comma 9. Okay, if it should be and 9 without a 5-digit number. 1, 2, 3, 4, 5. So if it has to be divisible by 4, in that sense, it should be a multiple of 4. So what are the multiples of 4? It can be like, it should be 4, then 20, then 24, then 40, then 52, 72, and 92. These are my possible, like, or like the if my last of the digits, like last digits are like the multiple of 4, then I can say that it is divisible by 4. Correct?
Yes, ma'am.
So I have to take all of the conditions. So this is 4 is actually what? 0, 4. Okay. So so my last two digits should be these numbers. So I have to take all of the cases like this. So first to take all of these cases. So in sense, let's suppose my last digit ends with, so I'm taking first case in which my last digit ends with 0 and 4. Okay. And they are saying that it is without repetitions, right? So I can't repeat. So 0, 4 is already out. So the 1, 2, 3. So 3 digit will be filled by how many digits? 0 and 4 is out. 1, 2, 3, 4. So this can be done in 4 ways, then 3 ways and 2 ways, correct? And 0 and 4 is already there.
Ma'am, where
Okay,
you
so
have placed 0 and 4, ma'am?
0 and 4 will be here, na? This is my 0
Ma'am,
and 4.
we can also take separately, no, ma'am. Two cases for 0 and for 4 separately
No, no, no,
because
no. This one main thing is if it should be divisible by 4, my last two digits should be multiple of that.
okay, ma'am.
Okay.
Yes, ma'am.
Okay. So now I will take the second case as well, in which my last two digits are 2 and 0. Then in that case also I'm having how many? Uh, just a second. It's so 24, 1, 2, 3, 4, 5. So my last digit is 2 and 0. So 4, 3, 2. In support, this will be 4p3. This is also 4p3. Similarly, you have to do for all of these cases. Okay?
Yes, ma'am. Thank you, ma'am. Got it.
Okay. Yeah. Anything else?
No, ma'am.
Ma'am, you just scroll up. I'll take a screenshot. Up first question.
Which one? This one?
No, ma'am. Before this.
This?
Before this. First. Thank you. Thank you, ma'am.
Now is it done?
Yes, ma'am.
Okay. That's it. Okay. So the graded assignment is done. So now the person who was asking about the EMQ thing can ask. Is he here or gone?
Yes, ma'am. I have posted a pic of the first two questions of the week's graded EMQ in the chat, just in case.
The organizing of an event needs to wrap 5 bottles. Five bottles, there are 10 unique designer wrappers. So you need the answer of question 1 and 2, right?
Actually, see, the problem that I have with this question, with this scenario, is the interpretation. Like, do you interpret this question to be a permutation or a combination question? Can I tell you why I have this confusion?
Uh,
See, ma'am, like the official answer states that, each of these five bottles are distinct, like distinguishably distinct, and, the order uh, of which bottle gets wrapped with what matters. So, suppose, say, bottle one, suppose there are five bottles named 1 to 5. One can have, 10 choices, two can have 9, and so on and so forth.
ठीक है.
But this question, could also be interpreted as a combination question for the following reason that I wish to state. If there is no, specific explicit mentioning of the fact that the bottles are distinct. One. Two, consider the following scenario that could, be somewhat analogous to this. Suppose there is a party and there's a drink server who has a tray of cups. Suppose say there are 5 cups or 10 or I don't know how much ever. The server is actually not, going to care about which cup gets first. He just has to fill all the cups, ensure that there is sufficient variety in his tray, and get serve it and get it done with. Like he only cares about the total number of groups that could be formed in his tray, more than which cup in the tray gets filled with what first.
Hmm.
Like, can you understand this analogy?
Mm, mm. So yes.
So what I'm basically trying to say is, if these 5 bottles are similar to the drink server scenario, and if these 5 bottles are indistinguishable, then all that matters is, picking, just selecting 5 wrappers out of the given 10 wrappers, more than selecting and then ordering them. And another thing,
The
the
yeah,
bottle wrappers is also mentioned to be distinct and unique. Yeah, it's not given distinct, it's given unique, but not so for the bottles.
The permutation is
So
because
if
of the
there are two
wrappers, not
different,
because of the bottles.
sorry?
The permutation will happen because of the wrapper, not because of the bottles. Because of the
Yeah,
uniqueness of the wrappers.
see, you can say that permutation happens only when you consider there are 5 distinct slots, right?
Yeah, but the
So there is
wrappers are
slot 1,
distinct, right?
slot 2, slot 3, slot 4, slot 5. No, one second. But these are distinct, and how do I say this? If I fill these slots, there is internal arrangement actually going on.
Yeah, I understand your point. The bottles themselves are not distinct. That is clear. But the wrappers are distinct. So because of that, you have different wrappers you can use. Like if you take the first 5 wrappers, you'll get five
Okay.
different bottles. If you take the next 5 bottles, you get different bottles, different wrap
Yeah,
bottles, right?
yes, but I'm
So
just
that is why the
selecting. No, I'm
permutation
not
happens.
ordering them. Yes, what you're saying is correct, but I'm just selecting them. Suppose I'm just picking 5 wrappers out of the first 5 out of the given 10. I'm just selecting them. I'm not ordering them.
Yeah, but once you wrap it, they become different, right? Because the wrap is different. So that is why the
You wrap
ordering
it once.
happens.
No, see,
If
yes, what you're saying is but they see. Suppose say there are 10 wrappers W1 to W10, and I'm picking W1 to W5. Okay. Hello. Now, as soon as I pick this W1 to W5, and I just ensure that W1 is wrapped to bottle 1, W2 to 2, bottle 2, and W5 up till W5 till bottle 5. Now, I am not going to change the wrapper. Suppose say W1 is wrapped to bottle 1.
Yeah,
I'm not
that is
going
fine.
to next.
But
Uh,
you've selected 5 wrappers, let's say. Okay, leave the 10 now. You've already
uh,
did a ran a combination and you got the 5 wrappers which are distinct. Now,
yes.
which wrapper will go to which bottle, that will also be permutation, right? Because the wrappers are distinct.
Yeah, but the thing is, if you see this as a
If they were
combination
the
problem,
same
it is not
wrappers,
going to
if it was
matter.
same wrappers, it is classic combination. But because the wrappers are different, it becomes a permutation.
No,
That's
sir. What I'm
what I
saying
understood.
is, even if you can see, this is something like, selecting a team of 5 from 10 distinct people, selecting a group from 10 distinct folks. Yes, the individuals of these of the 10, each person is distinct in a group of 10. But I'm not going to consider the internal ordering after selecting them. In this
It's
case,
not
yes, the
internal, no?
wrappers are distinct.
Once you wrap it,
Sorry, what?
once you wrap it, the wrapper
Yes.
becomes distinct. What is inside the wrapper, it is irrelevant. Get it? Because these are
No, see,
distinct wrap. If it was
yes,
something, let's
sir,
say
the
you put
wrap.
something inside the bottle. This is what I understood. Maybe it's different, but from my understanding that because it was mentioned as distinct, it will become permanent. If it was the same wrappers, then it's classic combination. So then you don't need to
No,
worry.
see, same wrappers is then there is only, how do I say this? You
Then
cannot
ordering
have
will
a
not
case
matter,
where
right?
there are
Because
same
everything
wrappers.
looks the same.
Yes. So there is only one possibility if all the wrappers are same. Literally.
So the only option is that because the wrappers are different, that is why it becomes a permutation. Because you can use out of the 5, you can use any wrapper for any bottle. So that becomes in itself additional sequence.
See, I'll just restate what my interpretation was. There are 10 distinct wrappers and there are 5 slots, the slots being the bottles. Now, if
Right.
these slots were distinct, as you or
No,
the
but the wrappers are
intended
distinct, right? The
yes,
slot doesn't
sir, but
need
the
to be
wrapper,
distinct. The wrappers are
it has
distinct.
nothing to do with the distinction, the distinctiveness or wrappers.
Obviously it does. Because you have 5 different wrappers. In slot 1, I can choose 5 options, right? Out of the wrappers. If they were the same, then it would have been the same. It wouldn't make any
No,
difference.
so, okay, oh, wait. Suppose these 10 wrappers are, let's consider these 10 wrappers are the same. Okay. If these
Yeah.
10 wrappers were all same, indistinguishable from one another, then whatever 5 wrappers that I pick is going to be same with whatever other 5 wrappers that I'm going to pick. So there is literally only one possibility. In that, if you
Yeah,
see,
that
if you see
in
the
that situation, you just do combination, right? There's no point of doing sequence
that
of
is also a
permutation.
combination, but what I had stated before, this is also a combination. It is a combination where there are 10 distinct entities that are already present, but of these 10 distinct entities present, I am picking 5. I'm forming groups of 5, to be specific.
Okay. Interpretation, I think that is, you can take it both ways. But the bigger set, I think, is permutation, right?
The
With the
bigger set is
combination, it is
obviously
always,
permutation. No, see,
yeah.
yeah,
So
please
if you
continue,
take
please continue.
on the higher side, I would, it would, like, does it negate the permutation? Is there a reason why you should not consider permutation? That should be
Like
clear,
there is
right?
see,
Combination, that
see,
is
that's where
clearly
my
stated.
that is where my problem actually arises. Like, how do you interpret this question? Do you interpret this question as a permutation question or combination question? If you interpret this as a permutation question, the official answer is valid. But since there is also a possibility where you can interpret this as a combination question, it becomes a combination question. The answer ends up becoming 10C5 rather than 10P5.
10p.
I think
Why
it's
that?
because of the distinct. That's my only
Yes.
point. If
If
it
the
Indistinguishable
was not
bottles are
distinct,
distinct,
yeah.
if the bottles are distinct, instead of
If
bottles, consider them as slot.
either side, I think it's because both of them are not distinct. If yeah, either one of them is distinct, then it becomes distinct, or the entire thing becomes distinct.
Sorry, can you repeat what you just said? Like,
I mean, if it was the same bottles and the same wrappers, then neither is considered distinct, right? But because one is distinct, when you combine them, it becomes distinct.
uh, how can you say that? Like, okay, suppose say what you're saying is true. So what you're saying is the bottles are indistinguishable. All the bottles look the same. So you have now 5 slots, and I'm going to fill these 5 slots with 10 distinct entities. But since each of these slots are indistinguishable from one another, uh, I'm going to have extra, like, suppose say I fill them in the standard permutation fashion. I do 10p5 arrangements over here. But since bottle 1 getting wrapper 1, and suppose say I just picked 5 wrappers, W1 to W5, to fill bottle 1 to bottle 5. Since W1 getting since B1 getting W1 and B2 getting W2, B3 W3, B4 W4, B5 W5 is the same as B1 W2, B2 W1 with the rest of the bottles having the same wrappers, and so on and so forth. You're getting extra 5 factorial over here.
Yeah, because you have more variety in the wrappers, right? The the type of combination of bottles that you'll get will be more because the wrappers are distinct.
All
This
right, fine.
combination will
So
always
how
be
do I
less
interpret? Okay, fine. How do I
because
now
it's
interpret
distinct.
this question? Sir, now how do I interpret this question? Do I see this as a permutation or a combination question? Because I'm getting now 2 different answers.
that I think
Okay,
ma'am can answer
so
better.
okay, 1 second. So why the main thing is why you can take permutation in the sense you have 10 distinct wrappers, right? So one is different from the second, second is different from the third, and like that. Correct? I'm having 10 different wrappers. I'm having five spots. Let's suppose these are my spots. Like you have or bottles, you can say B1, B2, B3, B4, and B5. Now one bottle is to be wrapped with one wrapper only. Okay, and it cannot be repeated. Yes, that is the situation, right? है ना?
Yeah, right,
Yes,
right.
the
हाँ,
10
Yeah, yeah,
wrappers are
exactly.
distinct.
ठीक है. So if they are all distinct, so this can be done in 10 ways. This can be done in 9, then 8, then 7, then 6, right? Correct.
Yes,
In this
Yeah.
ways,
but this actually implicitly assumes the fact that each of the
mm,
slot are distinct.
correct.
That right?
हाँ, okay, then.
But if each of these slots were considered indistinguishable, I am actually
So they
having
are
a 5 factor.
in the question only they are saying that they are distinguishable. So where it is written, it is indistinguishable.
It isn't, but there isn't a mention of bottles being distinct either. It just states the wrappers
Array,
are distinct.
see, there are spots to be filled. Okay, don't take the bottles now. Just take the spots, and you have to cover it with the different balls. You have 10 different balls. Okay,
Uh,
10 different balls you have. So one ball is you have chosen 10, like 10 ways you have to choose this. 9, 8, 7, 6. Are they distinguishable?
it depends on how you see them. If you see them, you see these spots are distinguishable, yes, the order matters. If you see them as indistinguishable, it
They are
doesn't.
distinguishable. They are distinguishable because this spot is not same as this spot is not same as this spot like that. So they are distinguished. You can distinguish between the spots, right? Yes or no?
Ma'am, it depends. No, it depends. It depends.
How it
It
depends?
depends. See, if
How?
you're seeing this as a no, 1 second, ma'am. If you see this as some sort of a code formation problem, yes, the order is going to matter. But if all that you care about is, what kind of characters that I wish in a given selection with no internal arrangements being considered, I'm not going to care about the order. My point of contention with this question is just the following.
Hmm.
Is there
Can I,
anywhere you can specifically find where you know for a fact that the bottles are distinguishable? Like for the design wrappers, for the bottle wrappers part, there is an explicit mention that the design wrappers are unique, but there isn't anything something like that close to the bottles.
Okay. So
Uh, since there are
so
two different interpretations, like why, like there's
I guess once a bottle
I do
is
not know if this
wrapped
question is
up,
valid or invalid, since there
uh,
are two
wa-
different interpretations of this.
see, what is my event? My event is I have to wrap the bottles. Yes or no? That
Yes.
is my event. Like I want that all my bottles should be wrapped by the designer wrapper. So that is my event. So there are, now let's suppose I am having I have five balls here. Five bottles are there, right? I have to wrap them. So so for the first bottle to be wrapped, there are 10 ways. Yes or no?
If you see, madam, if you see this bottle as a first distinct bottle, like if you're literally naming the bottle to be bottle one over here,
So are
and
you
then
saying
as a
that from the five bottles, first I have to select one bottle, then this selected bottle should be wrapped up with
I
the 10 wrappers,
I'm
like
not
that?
no, see, madam, I'm not at all talking about the selection of bottles at all. All I'm just saying is there are 5 slots in the place of these bottles. Of the 5 slots, I just have to select 10 and fill these 5.
Hmm. हाँ.
may I?
And the main problem that I have with this question is like, why does it have ambiguous wording such that you can interpret it in two different ways? Because I can't find
But what
anywhere.
is the ambiguous thing? Okay, see, I'm
Yeah,
not getting.
ambiguous thing is being the bottles not being specifically mentioned to be distinct.
हाँ,
That is the
ठीक है.
ambiguity over here.
Ambiguity, okay. Bottles are not distinct. If bottles are also distinct, then what is the
Then the given answer is yeah, it's correct. given answer is correct, and whatever explanation you were trying to give or the other person was trying to give is absolutely valid.
Okay. And if they are indistinguishable,
Then it becomes a problem of selecting 5 things out of given 10 things.
how?
Sorry, what?
How can you explain it to me?
How? Suppose say you have 10 people. You wish to form a team of 5.
No,
Are
no,
you
you
going
just
to
take
see?
this example only. Just give me this
Yeah, this
example.
example is
Complete.
that suppose, okay,
Hmm.
see, let us actually, for the sake of this discussion, name the bottles B1,
Okay.
B2, B3, B4, B5. Okay,
Okay.
I am naming them,
Hmm.
but since I know for a fact that B1 is actually same as B3 or B4 or any other bottle, B1 getting and suppose say I have already handpicked W1 to W5, and suppose say I only have these 5 wrappers in my hand right now. Now,
W1 to
B,
W5
yeah,
wrappers.
He's doing
yeah.
combination on the wrappers first and
Why?
then applying it to the bottles.
Why?
That
No,
is where it.
okay, no, just forget about the fact that there are 10 wrappers at all. Just assume that the number of bottles and wrappers are the same.
Okay.
Okay. So there are 5 wrappers and now there are 5 bottles. Now, but the bottles are indistinguishable. But for the sake of,
Okay.
for the sake of this discussion, let's assume they are
We have.
not distinguishable, numbered, labeled,
Okay.
named.
ठीक है.
Okay.
Okay.
So B1 getting W1 and B2 W2 up till B5 W5 is the same, literally the same as B1 getting W2, B2 getting W1, and suppose
It's
say
not
the rest
same,
of the
na.
wrappers
They
remain
they
same.
are
No,
distinct.
no,
These wrap.
no. That see,
Ma'am,
if you
ma'am,
name them, it becomes
yeah,
distinct.
yeah, I understand what he's saying. If
Hmm.
if you've already selected 5 wrappers, then that wrapper going on any bottle doesn't make any difference because you already selected the wrappers. But what you're not considering is the 5 wrappers that you did not select. You can select one wrapper from 10 wrappers, not from 5 wrappers. That is where your
See, I
calculation
am
will.
selecting, I'm just selecting 5 at a hand. I am not, if you select 10 wrappers, suppose I am selecting one wrapper out of the given 10 wrappers.
Yes,
Let's,
but see, the way you do it, forget about the bottles. Okay, just have 10 slots. Okay, I have
okay,
10
10 slots,
distinct
okay.
wrappers. Okay, I have 10 distinct wrappers. I have to put it in 5 slots. What will you do? You will select
5
one
or
out of
10?
10. Out of 10.
No.
Okay,
How
you will
many
select one
slots are
out of
there?
10. 5 slots.
5
Correct?
slots, okay.
I have to select 5 wrappers overall.
Okay.
And I have 10
Okay.
distinct wrappers. What will you do?
Okay.
I will do 1 out of 10.
10C5.
1 out of 9. Yes. So that is what you're doing. The bottles don't add any value to this question. It is just how you're going to select the wrapper.
Exactly. Now the given answer is actually 10P5 and not 10C5. What I am basically
This
arguing
is
is there are
10p5
two
only,
different.
right?
No, sorry, what?
The way you will
What?
do it is 10p5 only, right? 10 into 9 into
10P5.
8 into
No,
7. When you're
boss,
selecting just the
what I'm
wrappers.
see, no. 10P5 is that where, see, what is 10P5 basically is I take 10C5 and I internally arrange the 10C5 objects by 5 factorial ways. That is 10P5. Literally. Select and arrange is what permutation is.
Yeah, that is what I'm saying. So your answer will be 10p5, right? If you're just
10C5.
selecting 5 wrappers. No, in this sequence, in the slots.
If the
First you
slots
have to
are
select one.
distinct, no. If the slots are distinct, if the slots are distinguishable, yes, your order is going to matter.
No, that's what I'm saying. Because you have distinct wrappers, your order will matter because each time you pick a wrapper, you have limited choice of 9. If they were the same, then it wouldn't have
No,
mattered.
wait 1 second. What is the act of actually, filling slot 1 with 10, times slot 2 with 9 possibilities, times slot 3 with 8 possibilities, times slot 4 with
Okay.
7,
If there is
times.
one example like there are 5 slots, okay, and there are let's suppose there are 5 numbers, distinct numbers, 0, 2, 3, 4, 5, 6. There are distinct, and you have to fill up this. So this can be filled at how many ways? This first slot can be filled at in how many ways?
Is the slot, no, 1 second. Are the slots distinct or indistinguishable? That is important first when you are
Yeah,
asking this.
they are distinguishable.
They are
This is
distinguishable,
different
they are
from this.
distinct.
Huh.
Okay, continue.
So how many ways you can do it? You can, the first digit is to be filled in how many ways?
Is
6.
repetition allowed?
Huh? Repetition is not allowed.
Okay, then it is
6.
just how many digits are there? 6, sir.
6. Huh? 6, then
Yeah,
5,
6 feet,
4,
right?
3. Similarly, so this is the same case only. I'm having 5, let's suppose I'm having 5 bottles and these are my 6 wrappers. Okay?
Madam,
These
what you
are
are,
all distinct. These are all my
wait,
distinct.
that is, see, that is where my problem is. No way does it state that the bottles are distinct. No way does it imply that the bottles are distinct or indistinguishable. That is where that is where the ambiguity does
But
seem to arise in this question. That is all.
when a bottle is completely wrapped up with one paper, then it is distinguishable now, because it cannot be combined in with any other wrapper also, because it once it is wrapped, it is out of the count now.
Wait. Which is why I picked this, 5 wrapper, 5 bottle example. Suppose, say I
Yeah,
picked
but
the
okay. Let me explain. If we have a combination type, if we have 1, 2, 3, and 4, we can make a combination of 1 with 3, 2, and 4. Okay. But
no.
at the
Can you
same time,
no?
when we
Hello, once
permute
again,
it, we can get 1 with
Hello,
3. Yes.
hello. Your example is not clear. Like, properly state what items are present. What am I going to do?
I'm saying that if we are combining something or making combinations, then we can repeat something for me. Okay, if
You
we have
can't.
one bottle, and then we have 5 wrappers, then one bottle can be wrapped up with any of the 5 wrappers, right?
Yes, over there the possibilities are 5.
Then when the wrapper is wrapped up, then the bottle is out of the count. Then we have 4 wrappers and other bottle. Then nothing we can do with the first bottle. So
That
there is nothing combination can be done there
No,
with the
no, no,
first.
no. That very no. One second. That act that you're doing right now, right? The first bottle, assuming 5 possibilities. Suppose there are 5 possibilities and 5 wrappers. You assigning 5 possibilities to the first bottle, and then 4 possibilities to the second, 3 possibilities to the third, two to the fourth, one to the fifth, is implicitly assuming that order actually matters. That is what you're doing by this multiplication principle.
Then why do you, how you do you think that there should be a combination? We
For the
cannot
reason that
find
I
any
just stated.
combination there.
Boss, for the reason that I just stated, nowhere does it state
Because
But the
explicitly that
bottle,
the bottles
once
are
it is
distinct.
covered, it cannot be like
we
indistinct.
can
Boss,
we can we
see.
can't differentiate. That's why he's saying we can't differentiate. If we change the wrapper, uh, mm, after that we are not able to distinguish which bottle is which one. I think he is saying this.
If you like, let's
See,
suppose
let me
if you
If
have,
see,
let's
see.
suppose, like
different,
Hello?
in
if
like, let's suppose in general, if we talk, see, we have 5 bottles, right? And you have been told that you have to wrap it up with a distinct, you have different types of 10 wrappers. Okay. You have been given
Huh.
5 bottles. Okay. Just imagine like that. If you're going to wrap it, okay. So the first bottle can be wrapped in 10 ways. Yes or no?
but ma'am,
Yes or
but
no?
ma'am, hello,
Yes,
but
yes,
ma'am,
continue.
Just take
we
it
are
in general case. Okay. So that bottle is different. That bottle is wrapped up and it's settled, right? Now comes the
Yes.
leftover the 4 bottles. Yes or no?
Okay. Yes, continue,
Okay.
continue.
So now the fourth bottle, the second bottle will be covered in the 9 remaining. How many I have wrappers in 9 ways? Yes or no?
Continue, yes. And so on
Similarly,
and so
the
forth.
rest of the
Right,
so in general, if you
right.
take it as so all my
See,
bottles, if you have wrapped it up, it's like different,
uh,
right? So that one
no.
bottle,
See, just one second.
uh,
What you had just stated right now
uh,
implicitly accepts the premise
hmm,
that each of these bottles are distinct, unique,
hmm,
indistinguishable, labeled,
uh,
or something of that sort. That is what you
uh,
are implicitly assuming when you're doing this.
Yes, I guess.
That is where the key subtlety lies with this
yeah.
problem,
Yeah, but
with this question
actually,
actually.
when you wrap it, then it becomes distinguishable.
no,
Na? Then it gets out of
But
the
we are
count.
not
see,
able to differentiate
the question is
between
we are
bottles.
assigning wrappers to the bottles, right? That is my
Yes,
questions, right? That is my
you are
question.
assigning
If I'm,
wrappers to
yeah,
bottles.
I'm assigning to the wrappers to the bottle. That means they are indistinguishable, right? Sorry,
Bottles
distinguishable.
are indistinguishable. No, bottles are indistinguishable.
I'm just
See,
talking about the
no,
wrappers. I'm just
one
assigning
second.
wrappers.
Okay, wait, one second, ma'am. One second, ma'am. Suppose there are just 5 wrappers. For the sake of our discussion, assume there are only 5 wrappers and 5 bottles. Now you are assigning. Are you going to know which is bottle 1, which is bottle 2, which is bottle 3? No. And even after you assign, you're not going to know which is bottle 1, bottle 2, bottle 3 either. So in this possibility where there are only 5 wrappers with 5 bottles, there is only one possibility that you can form if the bottles are indistinguishable.
Yeah, that statement is correct. If you have 5 wrappers and 5 bottles, it doesn't
Apply the
matter
similar
which
logic
bottle it goes.
see. Okay, yes.
But
Now
here you
apply
have
the
10,
same
nah? You're
logic.
selecting 10 out
10.
of
Yeah.
5.
What is selection of
But
10? What is selection of 5 objects out of 10? Is it 10p5?
yeah, but the combination of 5 wrappers also are much more, right? It's not just 2. You will
Bro,
have one with
bro.
6.
Wait.
I guess what a sense is that when you combine something from combinations, you repeat something. Like if you combine wrapped a bottle once, in combination you can get that bottle again and trying wrapping it with other ones also. What I sense
That
in
is
combination.
no. Wait. Those are the possibilities that get eliminated in the combination, and those are the possibilities that get included in the permutation. That is why I'm saying come back to the formula. See, what is permutation? You select and then you arrange. Combination involves just selection only. I'm not going to do extra arrangement over there. Once I select, I'm done with it. There is
So
not going to be a
what
question
you are
of,
trying to say? Can you just tell me, like in short, what you are trying to
see,
say?
basically, this question is ambiguous.
Okay.
If it's not ambiguous, you please let me know where you can know for a fact that the bottles are distinguishable or indistinguishable. I had
Yeah,
assumed them to
just give me
indistinguishable.
different point of view. Like, can you just give me both of the point of view in the sense like the answer when it should be
See,
permutation and when it should be combination? Yeah.
wait, okay. The official answer assumes that the bottles are distinguishable, distinct. In that
Okay.
case, it is a case of permutation. The official answer assumes that this is a case of permutation. My interpretation assumes this was a possibility of combination. Official answer is 10p5. My
Okay. Why you are
version
thinking
is
as
10c5.
combination? Why you are
Sorry,
thinking as combination?
because the bottles are indistinguishable, order is not going to matter once I select the wrapper and getting done with the selection. That is all. Once I select 5 wrappers
So
out
you
of the
are saying
given
that
10,
so you are saying that after wrapping it up with the
Ma'am, I understood. Because the bottles are indistinguishable, if I wrap bottle 1 with one distinct wrapper, that doesn't make any difference, because if I take any other bottle and wrap it with the same wrapper, both of them are same because the bottle is the same.
Yes,
That is what he
But
means.
once a wrapper is wrapped, then it cannot be repeated, na? The wrapper.
yes, it
One
cannot be
second time you,
His
repeated.
point is
then
also
why?
correct, right? Because
That
you
is,
pick any bottle and you pick one wrapper, it will be the same as any other bottle because the bottles themselves are not distinguishable. So then, how does permutation come into the picture? That is his question.
assuming the bottles are indistinguishable.
Yeah, I got what you're saying.
if you take it in that sense.
Hello? Sorry, what did you just say now, ma'am?
No, I just like just think in that way. If you're just thinking in that way, if I'm having
Again, I'm sorry if I just sounded a bit rude, but I'm extremely sorry. I was just a little impatient now. Now, see, in case if you're finding trouble with this problem, you please take the analogous example of a drinker serving drinks at a party. Suppose he has a tray of only 5 cups. Is he going to, is he going to care about the order of the cups as to which cup got filled first, second, third, fourth, and fifth? He's just going to worry about the variety of drinks present. That is all.
Yeah, but if you want to see what are the number of possible combination of, but it will still be combination because the
But
sequence of the wrapper won't make any difference. So any five you select, yeah. Okay, I got what you're saying.
in bottles, we are not also involved in which wrapper we will go to which bottle. I guess
No.
W3
Because
can.
of the bottles, it becomes combination. If the bottles are not there, then it becomes permutation because you're just selecting
But
the wrappers.
we can go with W3 to B2, B3, anything, no? And then
Yeah, but
after
that's
it
what,
is
right? See,
assigned.
what his point is, you take, let's say, one wrapper, right? You wrap any bottle with that. That will become one event
Yeah.
because the bottles are the same, right? So then you have to reduce those from your number of options, right? And that is combination. If the bottles were not there, then it's pure permutation because you're just selecting 10 distinct wrappers. But because of the bottle, it becomes combination because the bottles are not distinct.
Yeah, the number of bottles and number of wrapper then.
Yeah, that's the confusing.
Okay, I'll just give me some time, huh? I'll just think about it. I need to process it. Okay, I'll just take that into account as well. Okay, in the next session, I'll just come uh, with the with the theory or with an explanation. Fine. I'll just do some search on it. Huh? Search on.
Okay, ma'am, appreciate it. But I just want to know one thing.
Huh.
Like assignment marks, do they usually get finalized, as in unchangeably finalized after 2, 3 days? Suppose say week 6 assignment deadline was yesterday. So is this week 6 assignment going to be finalized, say today or tomorrow, or like
No, the grade
can it
list,
be
I mean,
changed?
everything that is already like what is there in your portal, that is the final thing. Only the extra activity, it will be like it will be changed by after 2, 3 days, like 1 week or 2, 3 days after.
The reason why I'm asking this is because suppose say some error is found out at a much later time. A
Uh,
particular question was incorrect or the answer is incorrect.
that
So
that we will just take into if there is any issue like regarding that, then we will like do something or it will be like excluded from the evaluation or we will give the points to everyone something. So we will just see to it like what we can do with that. If we get a proper reason for that question, if it's a wrong
okay,
or not.
okay. Because I
So
suspect there is a okay, fine. I don't want to talk about this right now. I think you
yeah,
all
yeah,
of us
it's
must be
fine.
tired.
Yeah. No, it's fine. I got your point, but it's good. It's good. I'll also talk with the other instructors as well because I'm also now confused. So, okay, I'll just get back to you in the next section. Right?
Okay.
Yeah, sure. Okay, now it's also. Okay.
Okay, man, and okay, ma'am. Thank you, and thank you all. Have a good night.
Okay, that's it. Okay, then. Fine, everyone.
Thank you, ma'am.
Okay. Thank you, everyone. It was a nice session. Thanks. Okay, bye, everyone. Have a great night. Good night.
Thank you, ma'am.
Thank you.